Yeah, good day, my viewers. I'm here once again. Yeah, my name is Nicholas. I'm here for the purpose of those who are in need of solution to various problems in mathematics. So this is my next uploading. It has to do with logarithm. It has to do with logarithmic equation. In my last uploading, I treated indices. Right now I am treating logarithm. My viewers watching at me right now, I want you to press that notification button, subscribe and like. Now I know many students are always having challenges in mathematics, and that is the main purpose why I am here. I am here to create solutions to various problems in mathematics. Most students are having issues, are having challenges in their various mathematical problems. So I'm here to provide solutions to them. So I am starting with this kind of a question because I have realized that most students always have difficulties when it comes to logarithmic equation of this nature. Now, when you look at this equation that I'm having on the board, log base 2 raised to the power of x plus log base 4 raised to the power of x plus log 16 raised to the power of x equals to 21 over 4. So how do you break down this kind of equation? Is very simple. All we have to do here is to reduce all logarithms to base 2. We break down everything to base 2. And how do you break down the logarithms we are having here to base 2? Very simple. You reduce your 4 to base 2. You reduce your 16 to base 2. As you already know, that the lowest base we are having here is already in base 2. Now, as we all know, conversion of base 4 to the index form of 2 will give us 2 raised to the power of 2, and 16 is going to give us 2 raised to the power of 4. Now, for us to solve this kind of equations in logarithm, how do we go about that? Very simple. All we have to do is just to reduce all the logarithms to base 2, which is the lowest base that we are having here. That means you are going to reduce your 4 to its lowest base, which is 2. You are going to reduce your 16 to its lowest base, which is also 2. How do we execute this? Very simple. Solution. So we already have the lowest base, which is 2. This will give us log base 2 raised to the power of x plus, that is this sign here. Then how do you reduce this to base 2? Very simple. That will be log base 2 raised to the power of x, this x, over log base 2 raised to the power of 4 plus, then reduction of this to base 2 will give us log base 2 raised to the power of x over log base 2 raised to the power of 16 equal to 21 over 4. So this is the reduction of base 4 and base 16 to base 2. What do we do next? We have to find the value of log base 2 raised to the power of 4 and log base 2 raised to the power of 16. As we all know in mathematics, especially in logarithm, log base 2 raised to the power of 2 will give us 1. Log base 2 raised to the power of 4 will give us 2. Log base 2 raised to the power of 3 will give us. So log base 2 raised to the power of 4 is 2. Log base 2 raised to the power of 8 will give us 3. Log base 2 raised to the power of 16 will give us 4. So let me write it out. Note MP. So we have log base 2 raised to the power of 4 giving us the same thing as 2. We also have log base 2 raised to the power of 16 giving us 4. So we can have that on and on. Log base 2 raised to the power of 4 is 2. Log base 2 raised to the power of 8 will give us 3. Log base 2 raised to the power of 16 will give us 4. Log base 2 raised to the power of 256 will give us 8. Log base 2 raised to the power of 128 will give us 7. Log base 2 raised to the power of 64 will give us 6, and so on and so forth. Now all we have to do is just to substitute these values into the equation we are having above. So this is log base 2 raised to the power of x plus log base 2 raised to the power of x, which is this, then divided by the value of log base 2 raised to the power of 4. That will give us 2 plus log base 2 raised to the power of x, then divided by the value of log base 2 raised to the power of 16. That will give us 4. So which is this, we substitute, that will give us 4, then equal to 21 over 4. So this is what we are having from the above equation. So what we need to do next is very simple. Now from the equation we are having right now, we can easily take LCM. Since the denominator of log base 2 raised to the power of x here is 2, and the denominator of log base 2 raised to the power of x here is 4, but the denominator of log base 2 raised to the power of x here is 1, but it is invisible, not showing, but the reflection of it is this. So that is over 1. So that means for us to further on in this equation, all we have to do is just to take LCM. And how do you take the LCM of this? That means we have to find the LCM of 1, 2, and 4. The LCM of 1, 2, and 4 will give us 4, which is this. Now what we need to do next is to divide 4 by 1. That will give us 4. And we multiply 4 by log base 2 raised to the power of x. That will give us 4. That will give us 4 log base 2 raised to the power of x, plus you divide 4 by 2, that will give 2. Then you multiply the 2 by log base 2 raised to the power of x, that will give us 2 log base 2 raised to the power of x. Then the next thing for us to do is very simple. We divide 4 by 4, that will give us 1. Then you multiply your 1 by log base 2 raised to the power of x, that will give us the same thing as log base 2 raised to the power of x. Then everything is going to amount to 21 over 4. So which is this? This is 21 over 4. Now just like when we have 2 plus 1 to be 3, 3 plus 2 plus 1 to be 6. That means right here we have to sum up the value of log base 4 log base 2 raised to the power of x plus 2 log base 2 raised to the power of x plus log base 2 raised to the power of x. We have to sum it up. Now 4 log base 2 raised to the power of x plus 2 log base 2 raised to the power of x will give us 6 log base 2 raised to the power of x. Then when you add your 6 log base 2 raised to the power of x to log base 2 raised to the power of x, that will give us 7. That will give us 7 log base 2, 7 log base 2 raised to the power of x, then divided by 4, equal to 21 over 4. This is what we are having in this kind of equation. Then this is a very simple equation. What we need to do next, some students will like to cross multiply, but right here I am not cross multiplying. Since at both sides of the equation at my denominator level, I'm having 4 here, I am having 4 here. All I have to do is to cancel the 4 that I am having. So that means I am left with 7 log base 2 raised to the power of x equal to 21. I am having 7, that is 7 log base 2 raised to the power of x equal to 21. 7 log base 2 raised to the power of x equal to 21. What do I do next? Very simple. Since the coefficient of 7 log base 2 raised to the power of x is 7, and I'm looking for the value of x, all I have to do is very simple. That means I have to divide both sides by 7. So when I divide both sides by 7, that means my log base 2 raised to the power of x will be equal to 21 over 7, which is going to give me 3. That means log base 2 raised to the power of x will be equal to 3. Now in an equation like this in logarithm, you are looking for the value of x. What do? All you have to do is just take these 2 out, let these 2 carry the 3 as a power. When that is being done, that means from here, mathematically, our x will now be equal to 2 raised to the power of 3. 2 raised to the power of 3 in mathematics will give us 2 times 2 times 2, which is 8. That means solving the logarithmic equation, our x is equal to 8. Our x is equal to 8. My viewers watching at me right now, I hope this is helpful. Please, I beg of you, please go to the notification button, subscribe and like, and watch out for my next uploading. Thank you all. God bless you.